Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Hello, DubiousMobius by AQJHS. And here are the rules. We need to divide the grid into 10 orthogonally connected regions and place the digits 0 to 9 once each in every row, column, and region. So this is essentially a 10 by 10 Sudoku with the digits 0 through 9. And orthogonally connected regions, basically an example of that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be a valid example of an orthogonally connected region because you can go from any cell in this region to any other cell in this region just by going through edges while staying within that region. This, however, would not be orthogonally connected because to get from this cell to any other cell in the region, you would have to cross a corner or go outside the region. Another example of one which does not work is something like this. Because even though they can connect to each other from just by staying within, by going through edges, to connect to any other cell in the region, they would have to either cross through a corner or go outside the region. And that's typical chaos construction rules. We also have the grid is a double torus. That is, the edges of the grid are identified as coloring indicates. For example, R5, so row 5, column 10, is considered orthogonally adjacent to row 1, column 1. Okay. Regions and arrow sightlines, orthogonal and diagonal, wrap around the edges of the grid. Okay. This is kind of hard to see. But yeah. If you're colorblind, this is going to be really problematic for you. But basically it looks like it's double toroidal. So row 5, column 10 is orthogonally adjacent to row 1, column 1. Row 4, column 10 is adjacent to row 2, column 1. Sorry, row 1, column 2. And row 3, column 10 is adjacent to row 1, column 3. And it goes all the way here. This matches these. So these cells are orthogonally adjacent to these cells going up, right? So these match. Maybe that's one way you can do it. We basically just match. These are essentially orthogonally adjacent. With regards to and this one was orthogonally adjacent to that one. So then we have going this way. That matches this. This matches here. This matches here. And this blue would match here. Because of the way that it... you're matching essentially the colors here. So these would be corresponding to... These correspond to these. So R1, column 6, is orthogonally adjacent to R10, column 10, which is orthogonally adjacent to row 10, column 5. So these match this way. These 5 match that way. It's interesting. So... Okay. So regions and arrow sight lines wrap around the edges of the grid. Diagonals do not wrap across the singular points, which is the corners here. These little diamonds marked with the black diamond. Yeah. Okay. Cells marked with letters have the same digit if and only if they have the same letter. Only letters from the title are used, which is Hello, DubiousMobius. So cells marked with letters have the same digit if and only if they have the same letter. So these must be the same digit because they're both L. These are the same these three are the same digit because they're all O. These are the same digit because they're all U. Okay. Cells joined by a black dot have digits in a 1-to-2 ratio, and they belong to different regions. So so for example, if this is typical black crop key dot, which means if this were say 2, this would have to be a 1 or 4 to maintain the 1-to-2 ratio, and they are guaranteed to be in different regions. Cells marked with short blue arrows have a digit equal to the combined count of all the cells in its region that are seen in the direction of the arrow, including itself. And region borders break blue arrow's sight. So let's try to figure out an example here. So say we had the 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Say we had this, right? We have certain arrows. So this... Okay, so region borders break blue arrow's sights. This would then have to be 1, because it would just see itself. This would see 1, 2, 3, 1, 2, 3, 4, 5, 6 digits. This would see 1 digit because it only sees itself because region borders break blue arrow's sight. Obviously, this won't work then as a region. This would see 1, 2, 3 because it doesn't see any arrow digits in that direction because it's blocked by region borders. This would see 1. This would see 1, 2, 3, 4. So that would be 4. So those are examples of how blue arrows work here. Okay. Cells marked with the long red arrows have a digit equal to the count of different regions seen in the indicated direction, including its own, before returning to its own region. For an example, if an arrow in region A has a sight line that goes A, B, C, B, A. So let's say this was A, B, C, B, A. So this was one region type, A, B. We're going to make that B. We're going to make that C. And then it sees B. And then it sees A again. Its cell will contain a 3 since it sees regions A, B, and C. So it includes itself, so it always has to be at least 1, obviously. It could see itself. Interesting. Right, so it technically could just see itself, and then that would be 1, right? Huh. Interesting. And those are all the rules. There's a lot of them, definitely. What is that? Oh, I think it matches here. Right. So this is trying to tell you where it essentially matches in that direction. Huh. Interesting. Okay. So again, for the double torus, region and arrow sightlines wrap. Huh. I'm assuming it wraps that way then. Diagonals do not wrap across the singular point, marked with the black diamond. This matches here. Okay. This is definitely pretty crazy. It's a very hard puzzle, so obviously it's going to be crazy. Anyways, those are all the rules. If you like to play along, oh, that's interesting. Remember, these are the digits 0 through 9. But the blue arrows basically always include itself for the number of combined counts of all cells in the region seen in the direction of the arrows, including itself. And the red arrows must see itself because it must see its own region. So that must be at least 1, 2. So that's interesting. Anyways, as I said, these are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so all the arrow ones must be 1 at least. Do we? Okay. Also, these are in 1 to 2 ratios. And, okay, so all the borders are definitely black Kropke dots separate cells that belong to different regions. So these are all separate regions. This one's hard to see. Maybe I should make it red. Can you see it along here? No, it's still hard to see. Oh wait, no, we can see it. That was a black. It's not very easy to see though, because there's a lot of colorings here. Well, anyways, so this matches yellow, so it would be here, right? Okay. Hello, Mobius. Hello, DubiousMobius. Okay. We know this has to be for unique digits in these. Every row has contained unique digits. From 0 through 9, the only digits that are in a 1 to 2 ratio is if you have 4 of them in a row, and they're all unique, it's 1, 2, 4, and 8. So this is 1 or 8, this is 2 or 4, 2 or 4, and 1 or 8. Therefore, the B's are all the same because they mark the same digits with cells marked with digits have the same digit if and only if they have the same letter. So this must be the same. This is 2 and 4. That's interesting. That means L and... Okay, so L and O... I guess we could just mark these with letters, right? Well, we already see them, so we don't really need to mark those with letters. The rest of row... Okay, so this is 2 or 4. It sees this way. This is 2 or 4 that it sees this way. That's in the same region. This is 2 or 4 that it sees this way in the same region. So these must be the same region here. And it sees 2 or 4. This sees 2 or 4 in the same region. And this is the same as that one, right? The rest of row 5 has to be 0, 3, 5, 6, 7, 9. L is in a 1 to 2 ratio with... Wait. This is in a 1 to 2 ratio with itself? Doesn't that mean it's 0? Right? The only digit that can be in a 1 to 2 ratio with itself is 0, and L's have to be the same. Because, again, cells marked with letter have the same digit if and only if they have the same letter. Well, L and L have to be the same letter, so this must be a 0. So this is 0 and this is 0. Those are the only L's in the grid. That's interesting. And those are the only two digits that are in a 1 to 2 ratio, 1 to 2 ratio with itself. Okay. This is, okay, so this digit is in 1 to 2 ratio with two other digits. Therefore, this is 2 or 4. And it's with 1, 2, 4, 8 here, 1, 2, 4, 8 here. And the rest of the column cannot be 1, or 2 or 4, because one of the 2 or 4 has to be here. These are in separate regions, so we don't know if this is a 1 to 2 ratio with each other. This is 1 to 2 ratio. So one of these 1 to 2 ratios here. Oh, we do have O's together. So O is definitely some other digit. I guess this could go that way. This can't be 0 because of the 0 in the column. O is not 2 or 4. So this is specifically 1, 8 or 3, 6. If it's 3, 6, this would be 3, 6. If it's 1 or 8, this would be 2 or 4. U and D. D, I don't think we see another one, so we don't know if that's unique. U, we do see another one here. So again, these could be 3, 6, 1, 2, 4, 8. But we know, so in the rest of column 3, one of these has to be a 3, 6 pair. The other one must be 2, 4 with 1, 8. That means in the rest of column 3, you cannot have 2, 4, and you can't have 3 or 6. So the rest of column 3 must be 0, 1, no 2, no 3, no 4, 5, no 6, 7, 8, 9. So this is specifically 1, 5, 7, 8, 9 because zeros are already in the row. Again, all arrows will be at least 1. Oh, this has to be a 1. The blue region borders break blue arrow sight. It's pointing this way, and so the region border blocks that sight. It includes itself, so this is 1, which means this is 1. It's only in a 1 to 2 ratio with 2, so that's 2, which means this is 2. So these are in the same region here. Okay, so this can't be 1 or 2. This can't be 2. It could still be 1 here. So this can never be 1 here, because if this is 2, if this is 1, that would force that to be 2. This 1 eliminates 1 here. So this is 2 here, and then this is different region. This is 0 going that way. Hmm. This is very convoluted. Anyways, so this must be at least 2. That doesn't tell us very much, though. So what are the possible zeros in this grid? We already know these are the zeros to be in a 1 to 2 ratio with each other. This cannot be 0. It could be, what, 2, 3, 4, 6, or 8. And it's next to this one, which is cannot be 2. Can't be 0 or 1. So it's 3, 4, 6, or 8 here. This is 1, 2, 3, 4, 6, 8. Right, so this matches this. So the U's match. So this can't be 1. This can't be 1. This is 1, 2, 3, 4, 6, or 8. Okay. Hmm. This is O. So that matches here and here. So this is 1, 3, 6, or 8. Um, this obviously has to be at least 2. Um, Hmm. Hmm. This is 2 or 4 this way, so it could be these two are the same. Or it could go this way. Right, where are the zeros? This is obviously zeros, this is 0. 0 cannot be here. Or here or here. Obviously can't be in the same rows as a 0. So zeros in row 3 have to be 1, 2, and it cannot be E. Right? Oh, wait, no, it could be E. There is no other E in this puzzle, so this could be E. Technically, if and only if they have the same letter. Hello, DubiousMobius. So how many letters is that? L, H, we have Hello. So that's 4 unique ones. Do DUBI. So HELODUBI. That's 8. S and M. So that's 10 unique ones. Right. But we have no guarantees about that they probably have to be unique, I think. Even though they are not duplicative. Anyways, what are the rest of the digits in row? Where is the 0? Could the 0 be in row 4? Could be here. Cannot be any arrows. Can't be any digits with a 1 to 2 ratio with anything. Unless it's itself. Can't be these. Can't be H. Can't be arrow. It could be here. Assuming the letters are different. 0 could be here in row... Okay, this can't be 0 here. So 0 could be any of these 4. In row 6, it could be here, 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 not S, here. In row 7, it could be here, these 2, these 4. This can't be 0 because of 0 in the column. Row 8, oh yeah, this can be 0s, this can be 0. This can't be 0 because 0 in the column. Any of these. Row 9 could be these 2. None of these. None of these. So it could be there. And row 10. None of these. So that's one of these 2 and one of these 2. In column 9, we have only one place that can be a 0 because S is duplicated. I'm guessing E has to be a unique digit from L. So it cannot be that one. So this must be 0, which means this can't be 0 here. Okay. That's all we have right now. Okay, small arrows, blue arrows. This sees at most 4. 1, 2, 3, 4. But if it were 1, it would see its own region, so it can't be 1. It sees its own regions in the same way, so this has to be at least 4. Wait, but... So I guess for red arrows, it doesn't see it can never be 1. Because if it were 1, it never returns to its own region, quote unquote, right? Because otherwise this doesn't make any sense. So, right? Because if it stays in its region here, so these must be the same region. Because if it only sees one region, yeah, so it must include the region like it before returning to its own region. So it has to any cells that it sees along here. Just because of the way this arrow works, this has to be the red cells must start counting when it leaves the region. It can't just be you can't just basically say, "Oh, it sees its own region, therefore it counts 1." So that means none of the red arrows can ever be 1, which is interesting. But there aren't that many red arrows. There's a lot of blue arrows, which is why I was like, "Oh, okay." Oh, this sees itself, so it could be 5. Um hmm. Uh hmm. So none of the red arrows can have a 1. That's interesting. Does that tell us anything? Not particularly. There's not that many red arrows. There's a lot of combined blue and red arrows. Actually, there's a lot of blue arrows too. So, huh. Oh, this can't be 2 or 4. Right, because we know there's a 2 or 4 already in the column in one of these 3 digits. So U is not 2 or 4. Hello, dubious. So this is not 2 or 4, it's 3, 6, or 8. So this also is 3, 6, or 8. This can't be 2 or 4, it's 3, 6, or 8 here. Therefore, this can never be 1. This can't be 8, because if this were 8, that would force us to be 4, but it can't be 4 because of the U being here. Hello, DubiousMobius. So every letter in the title is or in the grid once. So H obviously is its own digit. E is its own digit. L is seen twice, and we know it's 0. D is its own digit. U is seen 3 times. B is seen twice. I is seen twice. Right, so this matches here. So that's 2, 3, 4, 5. So these must be the same region. Maybe make it red. It could be the same as the green region. We don't know. O is seen twice. Dubio. Mobi. Wait, no, that's I. Oh yeah, that's I. And then O's. O is here and here. And S is seen twice. U is seen 3 times again. So dubious. Mobius. S is seen twice. So these two are the S's. Oh, this has to be 1, right? Because the arrow points here. So this is 1, which forces this to be 2, and this to be 4. Because it points to that direction. It only sees its own region, and it's blocked by region borders. So this sees itself. This is 2, so this must be the same region. It only sees 2 regions this way. Interesting. So this I cannot be 4. DubiousMobius. Actually, I cannot be 2. Right? D is 2 or 4. B is 2 or 4. Oh, sorry. No, these are both B. Oh, never mind. That could be the case. Never mind. It could be 2. This is just the B and a B. We don't know what that is. Okay, the rest of column 9 has to be 3, 5, 6, 7, 8, 9. So this is also 3, 5, 6, 7, 8, 9. This is 4. So this is only 2 here, and it's blocked by the black diagonal, which makes sense. Oh, yeah, I could use black diagonals. Or black diamond diagonals. Hmm. Let's see. This is 4 going these directions. We don't know which. This is a separate region than this, so therefore this must be a region border that way. Hmm. It could go this way. It could go this way. It's only 4 though. Oh. This arrow points here. So this is only sees 1. So this is 1, this is 2, this is 4, that's 8. So this only sees 2 here. So this has to be a border that way. This is 4, this is 4. So this must see 4 this way. This could be the same region. We don't know. This sees both of these, so it's at least 4. This sees at least this way, so okay, so this is at least 2. This is at least 5 then. This is at least 5 also. This sees only 4, so this is a border here. This then must see at least one other digit here, because otherwise this would be the same as this digit, and we can't have repeats in the same row. So this can't be 4 here. This can't be 4 and 8. It's 1, 2, and 3, 6. This can't be 4, 8. So this is a 3, 6 pair, which eliminates 3, 6 here. So this must be 1 and 2 here. That eliminates 1 in the rest of the column. D is 3 or 6. U is 3 or 6. So this is 3 or 6, which forces this to be a 3, 6 pair. That means this is also 3, 6. This sees 4. This is 2. This can't be 2. Well, we already knew that. This is in the same region. This sees 1, so this must be a border here, and it cannot go to this cell here. O is the 1. Oh, wait, this is not U. Okay. Right, this is 3 or 6. Here. This has to be 1 then, which means these are borders. Because it sees only itself. This must be at least 3. This is at least 5. This sees the same amount this way, so it must see more this way. So this is at least 6. So this is 6 through 9. This must see 1 less than this, at least. 5 through 8. This sees all of these 2. It sees itself, it sees these 2. It does not see these. So this has to be 2 less than this. So this is 3, 4, 5, 6. This is, again, 1 greater than this, because this sees all the digits this way. This sees only 2 before it wraps to itself. Huh. That's interesting. This sees 2 that way. So this is yellow. Okay, so this can never see 9. Because it's... Well, no. Yes, it can never see 9 because... Oh, wait, no, there's 10 cells in a region. So it still could see 9. Okay. So if this is 3, it sees all 3 of these. Okay, so... Can this ever be 6 is kind of a good question, right? So this sees 2 regions before reaching it sees its own region again. This sees 4, so this has to be, these have to be the same region. Therefore, it's different than this region, definitely. So that's a border. Um, well, it could be 6 if it goes, okay, that way. Including itself. 1, 2, 3, it could be 4. 1, 2, 3, it could be 4. Hello, Mobius. So this is 1. So this is 1 also. Which means it cannot be seeing other cells there. This sees multiple because it can't be 0, 1. So this is a 1. This is also 1. Okay, how many regions can this see this way? Can this ever actually be 6? I think the answer to that is no. Right, it would have to go... This would then see 8, because this would have to see 6 this way. So it sees 6 this way. So then this would be yellow, and that would cross to here. So that would be 1, 2, 3, 4, 5, 6. Oh. This actually doesn't have to be 2 less than this. That's interesting. No, it does. Okay. So say this was 8. It would be 1, 2, 3, 4, 5, 6, 7. And then it would have to cross to here. 8. And then it would see itself. 9. So this can never be 8. This can't be 6. This could be definitely more than that. So it could be 1, 2, 3, 4, 5, 6, 7. Right, because if this were... Oh. Okay, say this was 8. This would see 1, 2, 3, 4, 5, 6, 7, 8. So it'd see 1, 2, 3, 4, 5, 6, 7, 8, and then it would see 9. Guaranteed. So this can never be 8. And it can't be 9 because then, even if this is 9, this would see 9, and it would be the same cell, same digit. So that's not possible. So this has to be different digits. This sees at least 3 regions before it returns to itself. And this matches here. So 1, 2, 3, 4, 5. So it could see 5, actually. Distinctly different sets. Unlikely, but it could see 5. Okay. This gray cannot be the same region as yellow, right? Yeah, they both have 4. So these are distinctly different regions here. It could still be the same as orange. We don't know. Could it be? Say it was the same region as orange. This would not be 2 anymore. This would have to see 3 this way. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then one of these, this can't be 4 anyways. So this can't be 4. This can't be 6 because this is always 2 more than this, right? This sees 4 this way, so it sees 1, 2, 3, 4 guaranteed. This sees 3 this way at least, or it could be 5. Can't be 4. It can't be more than 4 because then this would see, this sees 1, 2, and it sees these 3 at least. So that's 5 at least. So this is always going to be 2 more than that. If this was the same region, this would be a 3, 5, 3, 5 pair. So therefore, this would be 7, which would make this 5, that 3. Could that work? So this would be yellow. 1, 2, 3, 4, 5, 6, 7, 8. So this would see 5 this way. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, so that's too big. So this actually has to be a different region. So we guarantee this is a different region. Oh, we already knew that too because this sees 2 only this way. Yeah. Okay. This sees 2 regions and it goes to here? Yes. Ah, this has to see 2 regions, right? So this, yeah, that's the reason why this can't be. So this, well, it could be part of yellow, right? It could cut off short here. That's interesting. So say this was 5, right? 5, 7. This would have to be greater than 7. This would see 5 this way. So that's yellow. This would see 7 total. This would be a border. So this would be a border. It would see this, that would mean this is a separate region. So would you have something else there? This would be 7. We are guaranteed 1 at least here. This would have to see 5 different regions. And this would not be 5. So this would have to see 5 different regions once it starts seeing other regions. So that's 1, 2, 3, 4, 5, including itself. So obviously this is a separate region. This would be a separate region. This would be a separate region here and here. And that's possible. Not be 5 or 7. So far it's looking okay. Obviously it's very restrictive, but that seems fine. Okay. This cannot be 1, so this is at least 3. Can't be 0, 1, or 2. It could be 3, and then it goes up. It could be 3, cannot be 4. It could be 3, including itself. 3, no 4. It could be 5 or 6. So this is 3, 5, or 6. We are guaranteed these three are the same region. It could be the same as orange. This sees only... This is definitely a different region, though. So this has to be a different region. So this must be then 1, because it does not see anything else there. So this is 1. This sees 4, so this can never be 6. If this is 6, then this would have to be at least 6. So this is 3 or 5 here. This cannot see more than 3 digits this way. And because of that, where else can it see digits here? So this is 3 digits here at most. It has to be part of this. So this is part of this region. Guaranteed. So we have 1, 2. It could go 3 and then 4. Or it could go 1, 2, 3, 4. Or it could go 1, 2, 3, 4 that way. We just don't know. This sees 2. This is 4. Ah, this can't be 5 anymore. So this is 2 or 3. So this could be part of the pink region. If it's part of the pink region, it's 3, which means this is 5. That's interesting. Okay, so these digits have to be no 1, so it's 2, 3, 4, 6, 8. 2 cannot be here. This cannot be 1, again, because of the 1 in the column. So this is also 2, 3, 4, 6, 8. It cannot be a 3, 6 pair. If this is a 3, 6 pair, that would eliminate all possibilities for this cell. So this can't be 3 or 6. 3 or 6. It could still be 8. 4 is guaranteed to be one of these two. This can't be 3 or 6. It's 4 or 8. So 4 is guaranteed to be one of those two also. Okay. So the pink has to go up somewhere here, because we know this is a separate region. Well, I guess this could all be the same region, technically, so that could be the case. This goes to here, which means it goes to here. Can this ever be 8? I think... maybe. Yeah. Right, because if this is a separate region, it could be 1, 2, 3, 4, 5, 6, 7, 8. And then go that way to here, and then we go to there. We don't know where this region is, right? If this is a boundary here, that's interesting. What does that mean then? If there's a boundary here, this would then be 3, because it could be 3 at most here. This would be the same region. And this would be 3. This would have... That's actually interesting. We know the green region and the gray are separate regions, because this only sees 2. So this has to be a different region than this. What if this is the same region? So if this is the same region, oh, this is always going to, these three are always going to be in the same region, no matter what. If we have a border here, this can only see that way, so it's 3. If it sees 4 here, if this is not a border, these are the same region, well, this has to be greater than 4, it must be 6, and it can only see 2 more this way because this is blocked. So either way, these 3 are definitely the same region. We don't know if it's part of this region or what. Oh, I need a 10th color. Oh, no, we'll get to that when we get to there. If, well, I guess this could be 3. This could be the same region though too. So that's not a guarantee. This is definitely, well, could you go around? No, you can't go around. It would be really hard. Nigh impossible, in fact. Okay, well, we know this is a border and this is a border. Okay, so this is a border here. And opposite here, so that's a border. Two of these have to be at least in the same. Oh, this is okay. This cannot be. This only sees 2 at most, and it can't be 0, 1. So this must be 2. So this cannot be 2 here. This is 3, 4, 6, or 8. This can't be 2 here. So these have to be the same region. Interesting. Can this ever be 8? I think the answer to that is no. If this were 8, how would that even work? It would have to connect this and this at least, and that doesn't work. So this is 4 at most. This is 4, which means this can't be 4. This is 2 or 8. 2 or 8's in a 1-to-2 ratio with only 4. So that's 4, seeing that way. This is 4. So it either connects to this one or this pink one. We don't know which. These are in the same region. And it sees at least 3. So this goes 1, 2. So it's the same region as that, and then 3. So these are all the same region. So this is the same region. Seeing that way. These are all the same region. So this sees 2 that way. We don't know where it goes there. Can this ever be 6? I think the answer to that is no. Right, it sees this way. So this is that red that corresponds. It could be, if it's 6, yeah, it just can't read 3, 4. Oh, wait, it could be. Never mind, it could be 6. Arrows can never be 0. So this is at least 2. So these are the same region. Okay, that doesn't help too much. Hmm. This is 2 or 3, so this is 2 or 3. This can't be 4, so this is 3, 5, 6, 7, 8, 9. It could be 3. This has to be at least 1, but we don't have any other guarantee. So 1, 2, 3, 5, 6, 7, 9. Okay. This could technically be 1 also. Oh, this is 3 or 6. Because of the 3-6 pair here. So this must be at least green. Okay, that's interesting. So this is at least 3 because it sees itself and the others. So this is 3, 5, 6, 7, 8, 9. This can't be 2 because it's in the same region as the green. This can't be 8. There's an 8 in the column. Where is the 1? Where is 1? Yeah. In row 3. Can't be here because these see at least 3. This sees at least 3. Oh, this only sees 3. Because it sees 1, 2, 3, and then it's blocked here. So this is specifically 3. This is 6. So then this must be the same region. So this is the medium gray region. That means this blocks off here. This blocks off here. This sees 4. This sees 6. So this cannot be 6. The red could be part of that region, though. We don't know. This can't be 3. This can't be 3. This could still be 1. This sees 3 that way. This sees 2. This can't be 3. Hmm. So this is 6. That's interesting. If this is not... Okay, so say this was not 3. Wait. It sees 1, 2, 3. It can only see 4. If it is red here, this is not the same region. So this has to be 3. So this is 3 that it sees. Therefore, this is a separate region. So this only sees 3 because if it tried to see more, the problem is it stops here and this can never be 4. So this has to be 3. The green and the red still could be the same region. The pink is not the same region as the gray. It's because of the 2-4 pair split there. So this must go that way. These still could be the same region. So this could go this way. It could go this way. This is at least 5. So it sees 1, 2, 3. It could be 4 and then 5 that way, which would be here. That's possible. So it does not have to combine with the red. Okay. Okay, this 3 eliminates 3 here, so this is 5. Okay, so this sees 5 this way. So it's 5 here. Therefore, this can't see more this way. So this is blocked here. This can't be 5. Where's the other S? It's here, so this can't be 5. So we see that. This could be gray. That's fine. Orange. Can this be? It could be still the same region. This can't be 5 because of the 5 in the row. Yeah, we know this is already not the same region because, yeah. Could be like that. We don't know. So it's either 4 this way, or it could be 4 here, or 4 here. We don't know. It's 2, it's 3. Oh, this is 2 or 3. Cannot be the same region as the green. Right, this sees 3 here, guaranteed. This sees 2. So the red actually has to be a separate region than the green. Therefore, this must be 1. So this is a guaranteed 1 because it cannot be... This is red is part of this region. So this has to see 5. It sees 1, 2, 3. It must see that one, so that's green. It must see this one. So it must see that. Because, again, this is blocked off here. So it sees 1, 2, 3, 4, and 5 guaranteed. So this is 5. And then I don't know. Okay, so it would point in that direction? Yeah, and that's already blocked off. Okay. So this is a boundary, and this is a boundary, guaranteed. So this is a boundary here. This then cannot see 3, so this must be 2. So this is 2, so the eyes are 2. B is, so that's 2. So this is a separate region than this. Oh, that's interesting. Okay. Very complex right now. That means this 2 eliminates 2 here, so that's an 8, which eliminates 8 in the rest of that region. Okay, H is not a 2. We can't have 2 here. We can't... this could technically be 2. This could be 2 also. Let's just count what are the remaining digits in row 4. 2, 5, 7, or 9. And this can't be 2. Oh, it could continue on here. We don't actually know. So this has to be red or green, but we don't know which. Oh, green doesn't actually have to go here. It could be 1, 2, 3. So 1, 2, 3. We know this is guaranteed green, so this is not guaranteed green here. Okay, so then this just... Ooh, okay, so that doesn't have to be 2. Bad. Okay, bad assumption. So this does not have to be green here. It could be green this way. So this is green or red. We do know this is a boundary, though. So this still could be 2 or 3. Oof, okay. Well, never mind that. That's, yeah, that was a bad assumption there. Remaining digits in row 4, then, are 2, 5, 7, 8, 9. And this can't be 2 because of the 2 in the column. 2, 5, 7, 8, 9, 2, 5, 7, 8, 9. This can't be 2, though, because H is a well, it could be, actually. 2, 5, 7, 8, 9. So at least 2 of these are the same. This has to be 3, right? It sees 1, 2, 1, goes to here, 2 and 3. So this has to be 3. Okay, so this is 3, which makes this 2. Okay, there we go. That makes this 6. U is 6. Oh, we already knew that, though. Okay. Interesting. Anyway, 6 cannot be in the rest of column 9. This can't be 3 anymore because of the 3 in the column. 3 cannot be in the rest of this red region. So this is 3 here. I is 2, so that makes this 2. Okay, so then we do know this is blocked off. Okay, so this 2 eliminates 2 here, so that's 8, which means this can't be 8 here, and this can't be 8 here. H cannot be 2, because it's not, I is already 2. So this is 5, 7, 9. S is 3, 7, 8, 9. Oh, this isn't a 1 to 2 ratio. It has to be 6 and 3 because 1, 2, and 8 are removed. So this is 6, this is 3. That means this goes this way. Whatever region this is. So this is definitely a border. 2, I think it goes to here. Yes, so this is light. But it could be the same region as this, so we don't know. So this is 3 that way. Which means it goes here. And so therefore this is a border. Because this only sees 3. The rest of column 4 has to be 6, 7, 8, 9. It can't be 6 because of the 6 in the row. Oh, so this is 6. Right, so then this has to be green. Okay, so that's green. There we go. 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. Okay, this sees at least 3 this way. Okay, let's color this something else. Yellow? No, yellow can go wrap around. Let's make this a blue, I guess. So that sees at least 3. It could be 3 or 4, because otherwise it's blocked continuously. So this is 3 or 4, which makes this 6 or 8. This sees itself. Okay, so since it has to see these, this is light also. So that matches here. This is light, so this cannot be the same region. So we have a border here. This is already 4. So that could be the extent of it. Right, this sees 3, so the border is there. This must see 3, at least 3 regions before it sees another one. Wait, this could be 6. Why is that not 6? If this is 3 or 4, it sees 3 or 4. This has to be 6 or 8. So it must see these 3. It must see this one here. Because it sees 4 here. It needs to see at least 2 more. So in this direction. So these are both light. This is green. And there's a border here. This is light. So this is 6 or 8. This can't be the same region as this, so this must be 3. So this is 3, this is 6. This is 6. This is different region. So it has to see these 2, and then these are a separate region. So 1, 2, 3, 4, 5, 6. So this is a separate region then, here. This must see 3 regions going this way. So it sees 1. It must see 2 and 3 here before it gets back to the blue, and it will get back to the blue. Interesting. Okay. Let's see. What is this digit? It's not 1. It's not 2. It has to be at least 3. The red and the yellow cannot be the same region. So it could be at most 4 that for the yellow, if it's yellow. And it couldn't be 4. It'd be 3. Or it could be 4 this way. Or 5. So this could be 4 or 5. Cannot be 3. It's 4 or 5. So if this were part of the yellow region, that would not work. Because then this would see 5, and it can't see 5 this way. So this must be part of the red region. So this is red, this is red. Because it sees at least 2, 3 that way. It could see another one here, it could see another one here. So this is specifically red or yellow. That's interesting. This is a separate region. This has to be a separate region. Interesting. This could actually be part of this orange region here. This is 1, 2, 3, 4. That sees 5, 6, guaranteed. And it could be more this way. Actually, it would have to be that way? I think. It would go across here. And then go into there. So that would be there. So this could be green. I don't know. Interesting. This is 1. This cannot be 3. This is green, so it can't be 2. We have a contradiction here. Blue is a separate region. And this therefore sees 1. Oh, 2. No, it sees 2. It sees 2. It sees this region and then this region. So this must be a 2. Right. To see that, okay, so it sees there, it sees the blue region, and then it sees its own region. Right. This is 3. And is that different blue region? It could be the same region, but we don't know. Right, so this sees 2. This can't be 3. The remaining digits in row 1 have to be 4, 5, 7, 8, 9. This can't be 8 because of 8 in the column. 4, 5, 7, 8, 9 can't be 4 and 8 because of 4 and 8 in the column. This is 4, 5, 7, 8, 9. And this is at least blue. Huh. Technically, it could go through here. No, it can't, because that would block off this region. So this is definitely different than the light region. So it's blocked off here. It's part of the green region already. So we have 1, 2, 3, 4, 5, guaranteed 6. Right. 1, 2, 3, 4, 5, 6. This. Okay, so this is a boundary. Oops. This is a boundary here, which means this is a boundary there. So this can never be more than 2. It can never be more than 4, actually, going this way. So this is a 2. So this is 2. Okay. We know this is a boundary, so this must be a boundary here. Therefore, for green, it's 4 or 5 here. So it could be 4 this way. It could be 4 this way. It could be 4 this way. So this is always guaranteed to be green. This is guaranteed to be green. One cannot be green. So this is bordered by green and the light gray. So this must be light gray. Okay. So this is green also. This is a border. So this must be 4, and it must be these 4. So this is 4, and it sees only these. That means this is green. So this cannot be green here. This corresponds to here. So this is 4. This is not green. So this must see 1, 2, 3, 4, 5. It cannot see here because that would correspond to this 0, and we know this 0 cannot be green. So this must be the extra 6. So that's done. Therefore, this must be 4 and is not yellow. So these are borders. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So green is all done. So this is all done. So obviously this is not the same blue as this. I don't know. Pink, maybe? I don't know what we make this. So this is 2 that this way. Oh, this matches here, right? And it does see 2, so it sees 1, 2, 3, 4. And it must go that way. So it goes that way. Yeah, that sees itself. So that's good. Okay. This sees 3 other regions in here. So it sees 1, it sees itself, it'll see 1 and 2. So this has to be 2 other regions here. Blue almost certainly has to be included there. This can't be 2 because of the 2 in the row. It's 5, 7, or 9. This cannot be 3 or 8 because of the 3 and 8 in that region. So this is 5, 7, 9. This is an S. So that matches here. Okay. Three is a D, so this S cannot be 3. So L is 0. 1 is O. 2 is I. 3 is D. 4 is B. 6 is U. We don't have an 5, 7, 8, or 9. So it's this 5, 7, 8, or 9. 5, 7, 8, or 9. Okay. What does that tell us? I'm not really sure. We have 3, we have 4. The rest of column 2 has to be, what? 0, 5, 7, 9. Okay, this can't be 4. That's 5, 7, 9. So green is done. That's the only region we have. Okay. That means this is its not a region because this is blocked, right? Because we are done with green. We have one, 2, 3, 4, 5. This again has to be 4. So it counts itself and these 3. That makes this done. So this is 6 digits. We have 4 digits here. That's 10. So this is blocked off here, which means this is blocked off. This has to have 2 regions in it. So this is a separate region. I don't know what we're marking it as. This must be a blue. Because this has to go out somewhere. It can only go out this way. It can't be part of the pink region because it counts 3 going this way. So I guess this could be pink here. This has to go out this way. So we have a blue here and we have something else here. This is a separate region. So this has to be a separate region here. I guess I don't want to mark it orange. This is blue also. Ooh, that's bad. That's bad. That's very bad. Because light already counts as a region. We need 3 separate regions. Oh, it counts itself. It counts itself. It counts itself. It counts itself. Okay, okay, okay. So we're still good there. So blue does not have to go there. We know this is blue, though. This is separated out. This is green. So this is dark, which means this is dark. This is red. This is red, so this is a 3, and this is 6. This is matching that, so it's 2. So we're just going around the corners. 6, 6. Red. So this is 6, I believe. Yeah. And this is light. Right, so blue does have to be... So blue is one of these 2. We know that for certain. We don't know anything else, though, really. Okay, obviously this is a border. We have 6 blank blank blue. This is red. Okay. We have green, green, blue, blue. We don't know what that is. What do these match? This is green. This is not green. This matches here. This is light, so those are matching already. 3, 2, 1, whatever, and 4. This matches here, 3, 6, and we don't have any information. This matches here. No, this matches here. So this is dark, that's 3, that's all the information we have. This matches yellow. Yeah, that's done. Okay, so obviously these are different. This must go here, so this must be this. Okay, well, okay, we don't want those as double pink. Okay, let's add a color. We'll make this brown. We need 10 colors anyway, so. This cannot be part of brown. It must be part of pink. So this has to go to here. Okay, and then this has to go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is all done here. This is a gray region. So this is done, this is done, this is done. So this is 2. This cannot have 6 or 8 in the remaining digits in the region. So this must be 0, 5, 7, 9. Well, we have a 0, 5, 7, 9 quadruplet in row 7, which eliminates 0, 5, 7, 9 in the rest of the row. So that leaves the remaining digits as 3, 4, 6, and 8. This can't be 3 or 4 because of the 3 or 4 in the column. And these are 3, 4, 6, and 8, and that's fine. This 5 is pink, so this 5 is there. This can't be 5. This sees itself, so that's 2. And that's perfect. So this could be 4 this way or 4 this way. We're not sure. What are the remaining digits in row 6? We have 0, 3, 6, 7, 8, 9. This can't be 6 because of the 6 in the column. 0, 3, 6, 7, 8, 9. 0, 3, 6, 7, 8, 9. 0, 3, 6, 7, 8, 9. The blue could be part of orange, and in fact is very likely part of orange. We have 1, 2, 3, 4, 5, 6, 7. Okay, so to connect, it can't go around this, so this must be light also. So we have 1, 2, 3, 4, 5, 6, 7, 8. It could be 9. Okay, this light cannot be 1. We already have a 1 in the light. So this can't be 1. It cannot be brown. It can't be light. It has to be blue. So this is a blue here. So blue has to connect to here, guaranteed. So this is blue. That matches here. Okay. The light needs access to a 0. 1, 2, 3, 4, 5, 6, 7, 8. It could be here, so we don't know. This 3 eliminates 3 here, so the U is a 6. Oh, we knew that. This is 6, this is 6. So this can't be 6. This is 8, which means this can't be 6 or 8. This is a 3, 4 pair here. This 6 eliminates 6 in the column. This is 5, 7, or 9. Can it ever be part of pink? Maybe. If it's part of pink, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be the most. So it cannot be part of pink. This has to be a different region. Right, 1, 2, 3, 4, 5, 6, 7, 8. If it's part, that's 9 and 10 at most. It sees 1, 2, 3, 4 cells. So that can't be. This is a part of another region. So it sees 1, 2, 3, 4, 5. It has to be 5. I guess it could be part of blue. So it could be more than 5. Okay. But it would see 1, 2, 3, 4, 5, 6, 7 at most. So this can't be 5 or it has to be 5 or 7 here. This can't be 3 or 8 because of the 3 or 8 in the column. This can't be 8. This is 5, 7, 9. We have 5, 7, 9 here. What are the remaining digits in... Let's do row 2. Oh. That's interesting. It has to be 4 through 9. Obviously this can't be 4, 8 because of the 4, 8 in the column. But these could be 4. It cannot be 6 because it's in the light region. This digit, what is this digit? It cannot... Okay, so light and brown are different regions, definitely. Okay, so this is light also, I think. Is that colored? Yes, that was colored. This cell cannot be both light and brown. So it can never be more than 4, right? This is 4 here. This would be 4 here. So this has to be 1, interestingly enough. So this does not, these are borders. It could go here, and then pink could go there. That's possible. I guess it could have been actually 9, 7, 8 here, but basically 9 is removed as a possibility for that cell. This sees 3, 5, 7, or 9 going here and here, so this must be the same region. So it could be light here. This actually, oh wait, could this be light? That's 1, 2, 3. No, this is 3 cells. So this must be 3. So this is 3. It cannot be light because we already have 8 cells in light. That's the reason why. So this almost certainly has to be part of blue. It could technically go there. Huh. This 3, okay, so this is a separate region. This 3 eliminates 3 in the rest of the row. Oh yeah, none of these could be 3 anyway, so this is guaranteed to be 3. This is 4. This is already 3, so it includes either this one or this one. We're not sure which. It's only one of those, though. That's interesting. If this is not blue, so this is a border. We know that guaranteed. If this is not blue, it must go here, and then this is a border here. If this is not, if it is blue, it must go here, That's 4. Actually, it doesn't have to go. It could go here. Yeah, we don't know. Okay. Remaining digits in row 3 are 0, 5, 7, 8, 9. This can't be 0. This is 5, 7, 9. This can't be 0. We have a 5, 6, 7, 9 quadruplet in column 10, which eliminates 5, 6, 7, 9 in the rest of the column. This can't be 1 because of the 1 in that row. This can't be 1 because of the 1 in the row. This can't be 1 because 1 in the row. This can't be 1 because 1 in the row. So this must be 1. So these are, well, obviously separate regions. So that doesn't really tell us much. Does the dark have to connect here? Yes, because it blocks off other stuff, but it doesn't, so. Okay. Okay, so this is done. This sees 1, 2, 3. So it sees itself 1, sees 2, 3, 4, 5, and 6, and that's it. This sees 3 that way. That's fine. And it sees the gray, 1, blue, 2, and then its own, 3. This sees 2. It sees the blue, and then it sees the light gray region itself again. So that's 2. This is 1-2 ratio. This sees 4 here. This sees 3 going that way, and then it stops. This sees 1 going this way. That's fine. This sees 2 going that way. So this, it always has to be a part of this cell. Guaranteed. Because even if it goes here as brown, it has to go here. So these are definitely linked. I don't know, I'll make it dark, I guess. It can't go very far. Could be part of brown. Cannot be part of light. Because again, the reason why is this? Why can't it be light? Specifically here. Because this must be part of here, and this is definitely, yeah. Okay. This is essentially pink or brown. We don't, whoops. Pink or brown. We don't know which. This could be blue all the way there. So this does not guarantee that this has to be part of this. This can't be... If this is 4, it can only be all down. It cannot be part of pink. That's too many digits. 1, 2, 3. It can... If it's brown, it must include all of these. I guess it could be 6 that way. So this just can't be 7, 8, or 9. It's 4, 5, or 6. This is brown or blue. And this is brown or blue. Wrong color. Brown or blue. And these are brown or blue. These are blue or light. We're not sure which. Okay. Can this be a separate region by itself? It could be blue. It can't be a separate region. Okay, so right, these are kind of. Can this be? Well, maybe it could be. Hold up. 1, 2, 3. It can't be. This cannot be part of brown. This is 5, and this is 3, and they just don't connect. It could be its own separate region, and that could be part of this. Can it, though, actually? We know green's done. Light can only have 2 other digits. Blue can have a lot, right? We know we have a guaranteed 1, 2, and 3, 4. Brown has to have some too. Actually, yeah. This must be part of brown. This has to be part of brown. Because if it's not, where does the brown go to? Brown is blocked everywhere else. So this must be part of brown. Since this is part of brown, this cannot be brown. So this is pink, which means this can't be 5. So this is a border here. We have 1, 2, 3, 4, 5, 6, 7 guaranteed browns. So this must be brown there. It has to see at least 5. So we have 1, 2, 3, 4, 5, 6, 7, 8. It must be 9 and 10, or 9 and 10. That means all the browns are accounted for, so these cannot be brown. So this must be blue here. So this is blue. That means all of these are blue. So brown has to be 2 here or 2 here. So blue has to be here, which means this can never be blue. So this is a border. We have 1, 2, 3, 4, 5, 6, 7, 8 at most. So this must be part of blue. So this must be blue then. So this sees 4. It cannot be part of this. So this is a boundary. So it must see 4 here. So this must be blue. So this is all blue. Okay. And this cell cannot be, right? It sees 1, 2, 3. So it sees 1, 2, 3 here, and that's a 4th. So it cannot see what this is. So then this is not blue. This is light. So those are the boundaries there. This must be 5. Because it can only see 5 now. This must then cannot be 4 or 5, so it's 6. So it sees that. This is a brown. So this can't be 5 here. This can't be 5. This can't be 5 because of the 5 in the row. Where's the 5 in the green cell? It must be here, so this can't be 5. In the blue region, we have a 5, 7, 8, 9, 5, 7, 9 triplet, which eliminates 5, 7, 9 in the rest of the blue region. So this can't be 5, 7, or 9. It has to be 8. I think the blue region is all done, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, the blue region's all done. So the blue region's all done. This has to be a 6. So this is 6, 2, and we have a 5, 7, 9 triplet now. That means this can't be 6 here because of the 6 in the column. This can't be 6 and this can't be 6. Because of the 5, 6 in the brown region, this can't be 5 or 6. Brown. So this has to be brown because it has to be 5. So this is guaranteed to be a brown. And all the brown region is done. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the brown region is all done. So that's all done. This is 8. That doesn't help to tell us anything. We have a 7, 8, 9, a 7, 9 pair in the brown region, which eliminates 7, 9 in the rest of the brown region. So this can't be 7 or 9. That's 8. This can't be 7 or 9, so it's 0. That eliminates 0 in the rest of the row and the columns. Oops. So this can't be 0 here. This has to be pink because there's no other place for that to be a part of a region. This must be light. So that eliminates 0 in the rest of the light region. That also means, where's the 0? This can't be 8 in... Where's the 0 in row 3? It must be here. So this is 0, which eliminates 0 in the rest of the pink region. This can't be 5 because of the 5 in the pink region. That makes a 7, 9 pair in the pink region, which eliminates 7, 9 in the rest of that region. Actually, I think this is full, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So the pink region's all done. So this sees 4. This 7, 9 pair eliminates 7 and 9 in the rest of that region. So this has to be 8. This can't be 7, 8, or 9. This can't be 7, 8, or 9. This 3, 6 pair eliminates 3 and 6 in the rest of the row. So this can't be 3. This can't be 8. This 7, 9 pair eliminates 7, 9 in the rest of the row. So this must not be 7 or 9. So it's 5, which eliminates 5 here. Okay. So the blue region, the light region, the green region are all done. We have a 5, 7, 9 triplet in column 9, which eliminates 5, 7, 9 in the rest of the column. So this is 8. Oh, that matches the S here. Okay. So H is 7 or 9. E is 7 or 9. That means the M must be a 5. So this is 5, which eliminates 5 here. We have a 7, 9 pair in row 3, which eliminates 7, 9 in the rest of the row. So this is a 5. That means 5 cannot be in the rest of the light region. 8 can't be here because of the 8 in the column. Okay. We can mark each letter now, each 7, 9 pair as E or H. This is E, so this is E, this is H. That makes this H, and this E. So H must be one of those two. H is in the blue, so it cannot be here. Where is the H then in row 1? So this is E, that's H. This E makes that H here. H cannot be in the rest of the blue region, so where is the blue where is the H in 1? It has to be here. So this cannot be 5, which means where's the 5 in the green region? It must be here. So this is 5. This 7, 9 pair eliminates 7, 9 in the rest of the row 2, so this can't be 7 or 9. This can't be 7 or 9. It's 4 and 8. That's fine. This can't be 6 or 8 because of the 6 or 8 in the column. This is H, so this must be E, which forces this to be H. This H here means this is E. This red region does not have a 5, so this can't be 5. This can't be 5. We have a 0, 7, 9 triplet in the red region. Where is the red region? That means this cannot go this way, because we already have a 0, 7, 9 triplet in that region. We have a 5 in that region, and this is only 0, 5, 7, or 9. So this is blocked off here. What are the remaining digits in column 1? We have 0, 3, 4, 7, 8, 9. 3 cannot be here, 8 can't be here because of the 0, 3 and the 8s in the rows respectively. This 6 eliminates 6 here because you can't have and this can't be 8 either. We have a 7, 9, 7, 9 pair in column 4, which eliminates 7, 9 in the rest of the column, so this is 6. Okay. What are the remaining digits in column 5? We have 0, 3, 5, 6, 7, 9. 3 and 6 cannot be here. In column 5, then, we have a 0, 5, 9 quadruplet, which eliminates 0, 5, and 9 in the rest of the column. This can't be 0, 5, or 9, so this is 3. This can't be 3, so that's 6, which makes this 3. That means this sees 3 that way, so this is the edge of a border. This must see 5. And this could be 7 or 9, and we don't know which. So this sees 5. This sees 3. This 4's done. Okay, so let's maybe mark the ones as done. So 6 is all done. It sees 1, 2, 3, 4, 5, and 6. This 3 is done. It sees 6 as one region, blue. It sees light as one region, blue 2, and then itself as 3. And it sees 3 this way. This sees 2 in this direction. It sees blue, and then it sees light again. So that's fine. This is a border here. So this is done. This sees 4 digits in its own region. It sees 1 digit in its own region. This is 4. That's done. This sees 3 going this way. That's done. This sees 1 that way. It's done. This sees 2 that way. It's done. This sees 6 this way. That's done. This sees 2 going that way. That's done. This sees 1, 2, 3, 4, 5, 6. That's done. Because it would go that way, right? This sees 3 going that way. That's done. This sees 1. As it sees the blue, it sees the green, and then it sees, so this is 4. 0, 2, 6, right? So it sees, going this way, it sees blue, sees green, sees light, and then it sees brown. So that's 4. So this is done. This sees 1 here. That's done. 7, 9. This sees 1 going here, here, and here. So that's done. This sees 6 going this way and here. So that's done. 3 going this way and here. That's done. 4 in up and down. So that's done. 5 in all these 4 directions. So that's done. 2 going this way. It sees light, 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 light. And then it sees blue. So that's fine. This is a border here. Guess this is a border here. This is a border here. So this is a border here. This is not a border. This is a border. Okay, so this sees only 2, so that's correct. This 4 sees only 4 this way, that's correct. This sees 2 that direction and 2 going this way. Sees medium and then pink, so that's valid. This sees 1 going that way, that's done. This sees 3 going here, that's done. This sees only 2 going that way, that's done. This sees 5 going that way, that's done. This sees 1 going that way, that's done. This sees 1, 2, 3, 4, and then that's blocked here, so that's done. This is E. This sees 1 going this way, so that's done. This sees 2 going this way. We don't know about this, so that's not done. This sees 2 going this way. It sees pink and then gray, so that's done. This sees 4 going these, so that's done. This sees 1 going that way, that's done. This will be 1 going that way. It can't be the same region, so that's done. This sees 2 going this way, but we don't know about this direction. This sees 4 going that way, so that's done. This sees 3 going that way, 3 going that way. We don't know about this. We don't know about this. This sees 3, okay. Okay. This is E here, so this must be H here. Oops. H here. For the light region. We're missing an E in the blue. We don't know which one it is. H is here, so that means H must be one of these two. Okay. This can't be 4 because of the 4 in the row. This can never be 0 because it's an arrow. This goes to green. It's possible. Yellow has to be at least one of these two, and it has to be at least 7. Can it ever be 9? I think the answer to that is no. It sees 5 this way, and then 6, 7, or 6, 7. Either way, it can only see 8 at most here, right? 1, 2, 3, 4, 5, 6, 7, 8. So this has to be 7. Since it sees 7, it must be either 2 this way or these two. So this is yellow. But if it goes this way, this is blocked. So this cannot be this way. It has to be this way. So this is yellow, and this is a boundary here. So this is done. So this is its own region. It could be part of the dark region. We don't know. Okay. Remaining digits in... This can't be 3 or 4. This can't be 5 or 7. This can't be 7. We have a 0, 9 pair in column 9, which eliminates 0, 9 in the rest of the column. So this must be a 6. Remaining digits in column 6 are... This can't be 0. No 0, 1, 2, 3, 4, 5, 6. It's 7, 8, and 9. So this is 7, 8, 9. This can't be 7 because of the yellow region having no... We already having a 7. Remaining digits in column 7. No 0, 1, 2. It could be 3, 4. No 5, 6, 7, 8. So it's 3, 4, 9. And this can't be 3. It cannot be 9 going both of these directions, so this must be 4. So this is 4, which makes this 3, which makes that 4. That makes this a 9, which makes this 8. So this can't be 8 or 9 here. This can't be 9 here. This is 4. We don't know which way it goes. So this cannot be yellow. Because yellow already has a 4. Yellow needs access to a 1 and a 0, right? 1, 2, 3, 4, 5, 6, 7, 8. Well, all the 1s I think are done, right? We have 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And it cannot reach here, so it must be here. So this is yellow, which means this has to be dark. Because there's no other region it could be part of. So this is done. This must be a 0, and this must be 1. And this is all done here. So the yellow region's all done. Okay. This can't be 8 because of the 8 in the column, so this is an E. We have a 7, 9, 7, 9 pair in row 10, which eliminates 7, 9 in the rest of the row. This can't be 7 or 9. We now have a 0, 5, 0, 5 pair in row 10, which eliminates 0 and 5 in the rest of the row. This 4 eliminates 4 here, so this is 8. That means this is 2 here. This 8 eliminates 8 here, so that's 4, which means this can't be 4, that's 8. That's all done. So this must be 2 going this way. So these are the same region, and then it's border. That means, oh yeah, okay, well, interesting, okay. This cannot be red, so it has to be the other region, which we're going to make orange, I guess. So this is orange, this is orange. These cannot be the same region, but we don't know what those are. Okay, this is 3, this is 1, this is 5, and this is 8. Okay. So this is E, which forces this to be H. Is that right? Right, this is H, which forces this to be E, which makes that H. So this must be an E here. Where is the H in this medium gray region? Can't be here. That can't be this cell, so this must be an H, which makes this a 7, 9. This 7, 9 pair eliminates 7 and 9 in the rest of the region, so this can't be 7 or 9. This is 0. This has to be 5. This 0 means this can't be 0. This is 7, which makes that 3. So these 3 must be the same region, and then it's done. There's a boundary. So this is not dark. Hold up. Right, so this can't be 0. That means this is 7. So all the H's are 9. So all the H's are 9, and all the E's are 7. Okay, this 9 eliminates 9 here, so it's 7. This can't be 7 or 9, so this is 5, which makes this 0. That makes this a 5. This can't be 5. This can't be 5, 7, or 9, so this is 0. This can't be 7, so this is 9. That 9 means this can't be 9. That's 0. So this is 0, this is 9, and this must be a 7. But we don't want to finish it because we still have to do the borders. This can't be orange because it's a 6, so this must be red. The other 3 cannot be red, so it must be orange. And it must be 3 going that way, so this is orange. Can't be dark because that has to be a 3, so this is all orange. Okay, so where does that match? So this is 9, 1, 3, 0, 8, and these are all orange. This is a dark 7. This matches with here, so this is 7? Yeah. 7, 4, and 2. Okay. The red needs, so the red has 0, 2, 3, 4, 5, 7, and 9. So it's missing a 1, 6, and an 8. The 6 has to be here. Where's the 1? Can it ever access this even? Not really. These are, okay, this is, this matches with this. So this is 0. That's 9, 1, 5, and 8. This has to be 7, and this is 5. Okay, so 8 cannot be dark, so this is a different region. Actually, we know it's orange? Yeah, it matches here. So this is orange. So we know there's a boundary there also. This is a 7 that's dark. Oh, we don't know, actually. It matches here. This is 7 dark, 8 dark. So again, the red needs access to 1, 8, and 6. This is the only 6 that it can have access to. It needs 1 and 8, so this has to be 1 and 8. And that's the red. And that's the full red region. So these are borders too. So this is orange going this way, which means the rest of the region must be orange. So this is orange, orange, because it has to count itself as yellow. So this is all orange. So 0 and 9, 4, 0, 8, 3, and 6. This 4 is going this way, but okay, so this orange already has a 9, so this cannot be part of 9. So it must be this way. It already has a 0, so it has to be these. So these are all orange, and these must be all orange. And then it's done, right? Yeah, it sees only 4. That's fine. So the red is all done as a region. This then can't be red. It can't be orange. This 0, 9 is blocked off. So this must all be dark. Right? So these are all dark, and this is dark, which gives you all the entire region there. This must be orange, and this must be orange. Right? And this one is relating to that. No, it's relating to that, so this is red. Okay, so those are the boundaries then. This is an orange 5. And this is a boundary. Huh. Oh, we missed this digit. That digit is blue, so it's 9. And this is 9, corresponds to this. This matches that 4. This matches the 7, and this is 5. So that's the, let's just double check the arrows that we haven't checked. This is 2, points to 2 that way. It sees orange, goes to 4, and then sees itself, yellow, so that's 2. So this is fine. This sees 4 that way, that's already done. This is sees 3, that's fine. It goes, sees red, it sees dark, 9, and then it sees yellow. So that's 3 regions that it sees. So this is done. This sees 1 going this way, and that's done. This sees 4 going this way, and then it sees red, yellow, and dark before it sees orange again. That's 4, so that's good. This sees 2 going this way, and this stops at 3. And it sees dark region and then orange, so that's 2, so that's done. And everything looks kosher. This sees 3. This sees 3 going this way. It sees dark, it sees red. So it's looking this way. So it sees dark, red, and then it sees orange again, which is its own region. So that's 3. So that works too. So now we can fill in the final digit, and that's done. 7. Pretty crazy, but also pretty cool too. I like these. I love these types of puzzles because they're just, I don't know, they're just a lot of fun for me. Yeah, there's a lot of arrows. So there was a lot of information overload here, but I think it was well worth the going through the solve. This is definitely very hard. There's so many arrows and there's so many things that you have to take into account. But the logic flows actually very well, despite it being very difficult. Anyways, yeah, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.